as it heads back into the dark. There's no hurry. What you see mostly is the nucleus, a small body a few kilometers across, about the size of a small mountain. It looks like a rock covered in shadow, but it isn't just a rock. Much of what you're looking at is ice, hidden beneath a thin crust of dust and dark carbon-rich material that was left behind over the ages. And if you imagine a comet, you probably pictured something else, something bright, glowing, a long tail stretching across the sky. And from a great distance, that's exactly what this is. A wide, soft halo of gas and dust that wraps around the nucleus, and for hundreds of thousands of kilometers. And two long tails reach out ahead, leading the way as it travels outward, larger than some planets and certainly brighter than most. But we are not at a great distance. We are here, close. And up close there is no halo. The cloud is all around us. We are inside of it. It is so thin that we cannot see it. The tails stretch out in front of us, but from this angle they are invisible too. Up close, a comet is just this. A small, dark, ancient body, quietly losing pieces of itself to the sun. Look at the sunlit side. Thin, pale columns of dust rising from specific points on the surface. From far away, these are way too small to see. Lost inside the bright haze of the coma. It took a spacecraft flying close to see that a comet does not glow uniformly. It breathes in narrow directional bursts from specific patches of ice. Wherever sunlight strikes exposed ice, the ice turns directly into gas, a process called sublimation. No melting, no liquid, from solid straight to vapor. The gas escapes upward, lifts the dust with it, and out it goes, a jet of material reaching into space. As the nucleus rotates, its jet switches on when its source turns into the light, and it switches off when it turns away again. A slow, patient pulse, day after day, for as long as the comet stays warm. Let's talk about the body itself, the nucleus. For a long time, no one was sure what a comet really was. Some thought it was a swarm of small bodies, others a cloud of glowing gas, some are even smaller. A handful are tens of kilometers wide. The ice is mostly frozen water, but there's also frozen carbon dioxide, frozen carbon monoxide, methane, ammonia, and small amounts of more complex molecules. The surface is surprisingly dark, among the darkest things in any solar system. It's covered in a thin crust of dust and carbon-rich material, left behind as the ice underneath slowly turns to gas. Right now, while the comet is still warm from its recent path through the inner system, that process is in full swing. Every jet you see is part of it. The whole nucleus is humming with a quiet, slow exhale. In a few weeks, that will start to slow. In a few months, it will nearly stop, and the nucleus will become quiet again. But not yet. The cloud around us has a shape. Even though we can't see it from here, there is a structure to all of this. As the comet was falling toward its star, it warmed up. Not enough to melt the ice, but enough to begin the sublimation. Tiny grains of dust trapped in the ice for billions of years were released into space, carried out on the rising gas. That formed coma, a thin expanding atmosphere around the nucleus. And then the star took over. Light itself has a gentle pressure. Photons striking the dust grains push them outward, slowly, steadily, always away from the star. The dust drifts back from the comet, pushed and curved by that pressure, forming a soft, pale tail that follows the orbit. The gas is treated differently. Radiation from the star strips electrons from the molecules, turning them into ions. And then the solar wind, a constant stream of charged particles, sweeps those ions almost instantly straight away from the star. That's the second tail, a bluish ribbon of glowing gas, straight as a line drawn with a ruler. Both tails always point away from the star, not behind the comet's motion, always away from the star. On the way in, they trailed behind, but now on the way out, the comet is moving away from the star, and the tails are pointing even further away. So they lead somewhere ahead of us right now. Two enormous tails stretch out into space. We cannot see them from here, but they are there. This comet came from a long closer in beyond the outermost planet of a system, there is often a flat ring of icy bodies. In our own solar system, we call it the Kuiper belt. It begins past the orbit of Neptune, and it contains hundreds of thousands of objects, many of them small frozen worlds. Short-period comets, the ones that return every few decades or centuries, mostly come from the Kuiper belt. But further out, much further out, is something even stranger. A vast spherical shell of icy bodies surrounding the entire solar system like a thin cloud of dust around a candle. We call it the Oort cloud. Its outer edge may reach 100,000 astronomical units from the Sun, nearly a quarter of the way to the nearest star. There may be 1 trillion comets out there, possibly more, each one a tiny frozen relic, drifting slowly through the dark. Most of them will never come in, but every so often something disturbs one, a passing star far away, or the slow tug of the galaxy itself, a nudge so gentle it would take you years to measure it. And one of those frozen bodies begins very quietly to fall. The journey inward can take millions of years. This comet here, this one tumbling beside us, it made the journey a long time ago, and it fell silently for ages. And then in the last few months it came alive, and now it's going home. Comets are very old. This one and the ones in our own solar system, and the trillion others drifting in the Oort cloud, they all formed at roughly the same time their stars did. About 4.5 billion years ago in our case. When the cloud of gas and dust that would become the sun and the planets first began to collapse, the outer regions stayed cold. The ice never melted. The simple molecules never broke apart. The dust grains kept their original chemistry. And then most of that material got swept into planets and moons. It got heated and reshaped and layered under new geology. But not the comets. The comets that drifted out into the cold were left almost completely alone for billions of years. When we study a comet up close like this, we are not just looking at ice and dust. We are looking at a sample of the original material that the planets were made from. A frozen record of the cloud before there was a sun, before there was an earth, before there was anything. We have visited a few of these messengers. Some of it came from inside the young Earth, released as the planet cooled, but a great deal of it was delivered from above, by comets and asteroids, falling onto the early surface for hundreds of millions of years. For a long time, comets were the leading suspect. They are, after all, mostly water. The picture has gotten more nuanced, though. The water in many comets we've measured has a slightly different chemical signature than the water in our oceans. Asteroids may have contributed more than we used to think, but comets contributed, and they brought something else with them. Within their ice and dust, comets carry complex organic molecules, compounds of carbon, hydrogen, oxygen, nitrogen, the kinds of molecules that life is built from. Amino acids have been detected in samples returned from comets. On the comet Rosetta, the simplest amino acid, glycine, was identified directly in its coma, along with phosphorus and dozens of other organic molecules. This does not mean comets created life. That's a much bigger question, and no one yet knows the answer. But comets did seem to deliver at least some of the ingredients onto a young, warming planet that had just become quiet enough for chemistry to begin. Humans have watched comets for as long as we have watched the sky. In the records of ancient Chinese astronomers, there are observations of comets stretching back more than 3,000 years, carefully sketched and described, their paths traced across the stars. In many cultures, a bright comet appearing without warning was read as an omen, sometimes an omen of disaster, sometimes of change, almost always of something significant about to happen. But of course, what they saw was never really the comet. It was the cloud around it, the bright halo, the tails, the light scattered through the dust and gas. The actual body, the small, dark, tumbling thing, was something no one would see for thousands of years. Then, in the year 1705, an English astronomer named Edmund Halley did something quite remarkable. He took the records of 3 bright comets seen in 1531, 1607, and 1682, and noticed that they all followed almost exactly the same path. He realized they weren't 3 different comets, they were the same one, returning every 76 years or so. He predicted it would return in 1758. He did not live to see it, but on Christmas night of that year, a German farmer and amateur astronomer spotted a small fuzzy patch in his telescope small for us to notice, but it's cooling down, and in a few more weeks the sublimation will slow, and in a few more months it will stop. The dust will settle, the gas will stop flowing, and the jets will go quiet one by one. And the nucleus will become what it spends most of its life being, a small dark body drifting slowly outward. The activity we are seeing right now is the last bright moment of a very long life. The next pass may not happen for thousands of years, maybe even millions. There's something gentle in that thought that this small frozen thing has spent almost the entire age of its solar system doing nothing but drifting. And just now, in this brief window, it was awake, breathing, visible, and we got to see it, not from far away, not the way humans have always seen comets, but from here, close, beside it. Comets like this one have been passing by their stars for as long as there have been stars, long before Earth, long before the Sun. Some of the molecules in this ice, hydrogen, oxygen, carbon, are the same molecules in your body, in a glass of water beside you, in every breath you have ever taken. You are not separate from any of it. The ice and the ocean, the dust and the bone, the star and the eye that sees it. All of it is the same chemistry, rearranged, patient, beautiful. As we continue our journey, there will be more to see, more worlds, more wonders. For now, let the quiet of this small comet settle softly over you. Its jets are fading, but it will be a long, slow fade, and there is still plenty to see. Nothing to fear, nothing to do, just a frozen traveler heading home to the dark, and us beside